Hello! On this video, we'll demonstrate how to use Hawkular APM instead of ZipKin on the Red Hat Microservices Architecture. We assume for this video that you already have the Container Developer Kit, or CDK, on your local machine. First, let's start our Vagrant box. If you are already familiar with the MSA Hello World example, feel free to skip this video up to the 14th minute. While it starts, let's verify that we already have the relevant services on our local machine. For our purposes, those are the only modules we need. Alright, now that it booted, we can open the OpenShift web console. We have to accept the self-generated certificate, confirm security exception. We log in with the given credentials, and yeah, we see that it's up and running. It has a sample project, but let's also log in on the command line interface so that we can run the OC commands. We go back to the microservices architecture instructions and we copy the command to create a new project called Hello World MSA. Let's verify that it's created. Okay, good. For now, we are just going to follow the instructions on this document to create all the services on OpenShift. First, we start with the Hola service. It's a wildfly swarm service, microservice. Okay, now that it uploaded the image to OpenShift, we create a new application and finally we expose this application as a service so that people can access it from the outside. We also set a readiness probe to OpenShift so that OpenShift knows when that application is healthy, and with that it's able to switch the connections or route the incoming request from one pod to another one. We do the same thing with the Aloha example. This is a vertex example. Note that we don't have any changes on our local clones of those repositories. they are exactly as the upstream master was at the date that this demo was recorded. Now we create the new application Aloha, and similarly to the other example, we expose the service so that we can access it from our machine. We also set a readiness probe. Alright, and here we access the first version of that Aloha. Note that new version is built because of the changes we made. And note how OpenShift will scale down the old one only when the new one is ready. Now the first request to that pod might take a while. But subsequent requests should be very fast. Let's see. Yep. Okay, let's move on to the next one. Now it's Ola or Ola. We create the build. Now we build the package and we upload the image. The Ola example is a Spring Boot example. On all those examples, we externalize the ZipKin server URL as an environment variable. That's the key part for us to make a non-invasive change from one ZipKin server to the APM server. Now I create the application and we expose the service. Let's open to see if it works. Oops, there's something missing. Okay, let's just send the patch command and create the readiness probe. Perhaps it just needs some more time. We follow the instructions with the Bonjour application now. The Bonjour example is a Node.js with Express. Okay, the Ola example works. Note that we have a Swagger integration here. Swagger is a tool to document our REST endpoints. But let's see if our API is working. Yep, so the third deployment. That makes sense. As this is a completely new stack for our demo, it has to download different layers, different Docker layers. In this case, it's a Node.js application, whereas for the previous examples, we were using a Java base image. Okay, it's uploaded. Let's create an application and expose it. let's create our readiness probe. Now we're going to deploy the API gateway. So the API gateway is an example of a technique that shows a service that makes calls to other services. So it's a unique service that the UI could access, and it knows how to redirect those calls to back-end services. So we just checked the Bonjour application. It's working, it's fine. Okay, we expose the application. Create the readiness probe. And we can see on OpenShift that a new deployment is created. We're going to skip the ZipKin server and UI as well as the kubeflix because it's not the main purpose for this demo. So we just create a new build for the front end. We start the build based on the source code that we have on our machine. And we just check the API gateway. So note that the API gateway makes calls to the backend services, and we see that we have calls to all the 4 services there. As we are not going to deploy some of the services from the official instructions, we expect the front end to show an error when trying to access the kubeflix or Hystrix or the ZipKin parts. So that's kind of expected. Now we see that the UI is calling individual components. Now the API gateway and the service chaining is also working fine. Yeah, we just click around, see everything is working as expected, and it seems it is. So the browser as a client calls individual endpoints by itself, whereas the API gateway, the browser makes one call to the API gateway, which in turn makes individual calls to individual components. And the service chaining is the browser makes a call to one of the services, and each one of those services calls the next one, adding that payload to its own payload. So in the end, we have the payload for all the 4 services here shown on the browser. Okay, now that we have the instructions from the MSA, at least for the modules we want, we follow them and everything is working fine, we're going to deploy our APM server. So we create a new app, and this means that it will try to get the JBoss/Hawkular APM server from Docker Hub, but we're going to use our local machine or code from our local machine. Yeah. So we create a new build, and saying that this build is a binary build for the Hawkular APM server, and then we start a new build based on the code for the directory we are currently at. If you want more details on how to deploy Hawkular APM on OpenShift, check out our previous blog post on this subject. We see that our APM server is already shown there. It detects that we are building the image, and we just need to expose the service, and we can see on the background here that it created a URL for our service. But before we access that, we need to make note of the username and password. Those are available on the deployments log. So we just copy it into a text editor. Now we hit the URL for our APM server. Okay, it's deployed. It's asking for username and password. Yeah, and we see no data here. So every service is already deployed. It's sending data to ZipKin, but we don't have a ZipKin server running, so this data is just getting lost. But we are going to change that. We are going to set the ZipKin environment variable to point to our APM server, and with that we expect the data to start flowing into our APM server. So we do that by running OC commands. This command just overrides that var for the pod. So note that we have done no change to the code themselves. We just changed the environment where it runs. For OpenShift, it means a new deployment, and that deployment will be available once it finishes and once the health check passes. So once that happens, the old pod is scaled down to 0, and every request then reaches the new pod with the new change. So at this point we should have already some data, but let's just make some click around just to see if we send some data. Oh, we had one already. Okay, so let's just refresh. Let's make note. So we have the Hola 2, Hola 3, Bonjour 3, and Aloha 4. Right, so we expect, so some of them were probably deployed already, but we expect some of them, so to increase, that happened already, that was fast. So we have now Hola 3, Hola 4, Bonjour 3, and Aloha 4. So I think, we see some data already. Let's check that everything was deployed and ready. Yep, looks good. So let's just click around on all the screens. Each one of those shows a different kind of visualization on APM. Right, so let's refresh the results for the browser as a client, API gateway. Let's click around. Let's make sure we have some data there. Okay. So we see down there that we have 3 pages of results already. It's common that the first requests will take longer. Let's open the distributed tracing page. This is where we can see how one request has spun through services. So in this case, we have the the Ola chaining endpoint calling the Ola chaining, calling the Aloha chaining, and then calling the Bonjour endpoint. Let's check the most recent ones. You see that it's the newest one is faster. And now we see here the yellow boxes. They are the consumer parts of the call, whereas the blue boxes are the producer part. So we see how the chain works here. So each service calling the next one, and yeah, that looks pretty much right. Okay, now let's take a look at the other call. Note that we have some calls to Bonjour, which is our JavaScript example, and that has a bug on the client library, which was fixed already on master. So this is our API gateway example. So the API gateway makes parallel calls to individual services. So we have a different representation here. So API has the 4 consumers. It knows about it knows how to call the Bonjour service, the Hola, the Ola, and the Aloha. And each one of those consumers then call the backend service, and we get this representation here. So we see that we have 16 calls to the Hola and Ola, 18 calls to Aloha, and 17 calls to Bonjour. And note that the only thing we did was to change the environment variable, and we can see that on the UI here under the deployments environment. And let's look at the third deployment. We see that we have no environment variables there, so it was to trying to get the ZipKin server. And for the fourth one, the one we changed, and we just pointed to the APM server, and it just worked. Yes, that's it. Thanks for watching.